Hi, this is Dr. Craig Hillman,
and Dr. Nathan Blattell.
and we're from DfR Solutions. We have developed a series of short videos designed to help you, our customers, learn how to use key features of the Sherlock Automated Design Analysis software. Sherlock, as most of you already know, is a unique tool that is used by electronics engineers and designers across multiple industries to help them develop better, more reliable products. Like any good software tool, Sherlock has a lot of individual features. We today want to be able to show you, our customers, firsthand how to use some of the more popular and important features available within the tool, and just as importantly, how to avoid some common mistakes. Today we're going to talk about mount points. Nate, what's a mount point?
The mount point is the physical constraint of the circuit board. It's how the board is prevented from moving.
So give me an example.
For example, if the board can be constrained due to an attachment to a housing, board-to-board connection, stiffeners, etc.
And so why would I, as a user of Sherlock, care about mount points?
Well, the mount points provide the boundary conditions for the finite element analysis. So if you're doing a vibration simulation or a shock simulation, that's how the board is constrained, and that's how the boundary conditions are defined.
So wrong mount point, wrong vibration results.
Correct.
All right, okay, so that sounds pretty important. All right, so if it's really important, I've got you can see I've got my Sherlock screen up here. I've got my famous PCIe FPGA demo board. Where would I find these mount points you're talking about?
Well, the easiest way to view the mount points is through the layer viewer, and to access the layer viewer, you can really click on any of the plot files or the drill files. So
that's these things right here, right?
Yep.
These are all my, I guess, under files. That would kind of make sense.
Or under inputs.
So what would I click under inputs to get to that layer window?
You can click on the drill holes.
Drill holes. Anything else?
Pick and place.
Pick and place. And I get layers?
Yes.
All right. So what would you recommend? If I want to just look at these mount points, what should I click on first?
Drill holes.
Drill holes. All right, I'm going to click on those drill holes. All right. I've got my layer window up here. I've got this beautiful board outline, and I've got a bunch of gray dots. What are these gray dots?
Those are the plated drill holes.
Okay. This is where they drill through the board to kind of get that signals going through each other, top to bottom.
And to provide mounting locations.
Okay. So where are my mounting points?
Well,
are all these mounting points?
Some of them may be potential mounting locations, but because mounting points are mechanical fixtures, they are under the mechanical menu item in your tree there on the left.
Right here.
Correct.
Under mechanical folder. So if I double-click mechanical folder, a bunch of things come up. Has anything changed?
Yeah, you can see that those four corner plated through holes are now black.
It's kind of hard to see. Let me zoom in here for people watching. Oh, I see. Yeah, these are gray. I see, and these are black. Is there any way to kind of tell whether it's a mount hole or not, versus black versus gray? Maybe I'm kind of gray colorblind.
That would be a hard colorblind to be, but go ahead and just turn off your drill holes. And there you go.
Oh, look at that. I guess I also could tell if I went to the edit window as well, right? You know, like the edit mount point?
Right. To get to the edit menu, you do the edit mount points. Right. And then if you just want to right-click on that. And
oh, look, it's surround in red. That tells me that's a mount point. But here,
you get nothing.
Zoomed out. I'm going to zoom out. All right. So all right. So I've got these four mount points here. 1, 2, 3, 4. That's where I'm mounting things. I guess I've decided. Let's say it's a mechanical designer, so I'm going to put my mount point. How do I do anything with these mount points?
Well, the first thing we should go over is, how to add a mount point. So there's two ways to add a mount point. I can hold down the Shift key and left-click on an existing hole.
Oh, look at that!
That will associate.
Showed up.
That will associate that mount point with that hole.
That's really easy.
Yeah, that is the preferred method for assigning a mount point to a hole in your board.
Okay, so if you were sitting next to me as a user of Sherlock, you would tell me, listen, as much as possible, if you're going to add a mount point, do a shift click over a hole.
Right, and it's associated with that hole. So if you try to move that mount point off that hole, do a left shift or just a left click on top of it and drag. Just left. You'll see it snaps right back to it.
Oh, that's clever. I like that.
It's associated with the hole.
Okay.
The one thing you do not want to do is add a mount point to an arbitrary location of the board and then drag it over top of a hole.
So I shouldn't do something like this where I kind of do a right-click, add a mount point. I guess we'll just do that right now.
Well,
square. And move it square. I guess we're not going to use square holes, but I don't want to do that. That's
bad.
Don't
want to do that.
Okay. All right. I'm going to delete that mount point because that's bad. All right. So I've added a mount point. Is it that easy?
Yes. But now you can actually refine or tune the properties of that mount point.
So I should go back to our little mount point here, and I should click Edit Properties.
Yep.
Okay. Now, if I bring this as my Edit Properties window up, I see this really neat picture show up, and it says Mount Hole. Are there a variety of mount points I can choose from?
Yes, there's about, I think, 4 or 5 different mounting points. I think there's
under types.
Under type, there's 4.
Okay. Mount hole, mount pad, standoff, and support pin.
Correct. And these are just different ways the mount point is constrained. So an ideal mounting point is what we call a mount hole, and it just takes. Actually, there's a subversion of that, which is center constrained versus outline constrained. But in its basic configuration, you want to do the outline constrained, and it's just going to secure that mount point all along the perimeter of the hole.
Let me get it so that center constraint. That's these little kind of red and blue dots right here.
Correct.
Right here, and I can change that by changing this little drop down.
Yes.
So the default is outline. That's what you want us to do.
That is the basic mounting configuration.
So what's this next thing here? I've got a mount pad.
So a mount pad has actually develops a 3-dimensional structure attached to either the top or the bottom of the board with a known height with a material.
So that's down here.
Yep.
So I can choose top or bottom. That's right here. And I can choose any material I want. That's aluminum. I like a little brass. Brass is very pretty. I can do brass. Pretty yellow color. Nickel chrome. Would be strange. Okay, and then even I can use like polymers, like polyester.
Correct.
Right? I've seen plastic, standoff.
Exactly, all the time.
So if I have a standoff, should I use a mount pad?
Yeah.
All right.
And yeah.
And so how will the board behave differently if I said mount hole versus mount pad?
The mount pad will add a little bit of compliance to that location. You have,
the board will that location will kind of jiggle a little bit more if I had a mount pad versus a mount hole.
It's not perfectly rigid anymore.
All right. Well, then the third option is standoff.
Right.
Right. Now that looks the same as a mount pad.
It is very similar, except with our particular definition of a standoff versus a mount pad, is a standoff actually allows rotation at the base. So there's only one node at the base. It allows it to pivot at that location, but it's constrained in the displacement directions, X, Y, and Z, so it can't translate, but it's allowed to pivot.
So if I understand it correctly, it holds my board down. My board won't go up or down, or side to side, but my board could potentially rotate.
Correct.
So I guess a lot of standoffs are just kind of like these screws, right? Are you saying that with standoffs, like these round screws, or it's pretty easy to, it just adds additional compliance?
Exactly. It adds additional compliance, and it allows it to rotate.
So if I go from mount hole to mount pad to standoff,
you're getting less compliant.
More rigid to less rigid,
exactly.
Less compliance to more compliance.
Exactly.
My board is going to shake even a little bit more. All right. And then the last thing is, I guess I see, is this thing called a support pin. Now, when do I choose a support pin? All these material stuff has kind of gone away at this point.
Support pin is actually just a nodal or a point support. So just a single point in the mesh will be constrained. And again, since this is a 3-dimensional mesh, it's only going to be in translation, X, Y, and Z. So it will be free to pivot, just like a standoff, but you won't have that compliance. So this is somewhere in between, because it's only a single point, it may be a fairly compliant, but it's another ideal mounting condition.
So let me see if I give you a couple of examples. Can you tell me which one you'd recommend?
Yeah.
Let's say a press fit connector. Right. I got a press fit connector into my board. Do you think I should do a support pin, a mount pad, a mount hole, standoff? I guess probably a mount. A mount. I really.
Worst one.
I push Nate very hard.
Ideally, for there are size limitations to standoffs, and until we get rid of that, for a compliant pin connection, you're going to have to do a support pin.
Have to do a support pin.
Yeah.
Okay. If you want to actually constrain each individual hole.
Correct.
I could constrain over the entire connector. That'd be another option, right?
Yeah.
If I want to constrain over the entire connector, what would you tend to recommend?
A mount pad.
A mount pad. Because press fits are pretty rigid. They're pretty rigid things.
Yeah, it's press fitted into the board. It's
got a lot of pins coming down.
Yep. You're not going to get rotation there.
Okay. Let's say I just a simple standoff, like a nylon standoff. We see on a lot of these kind of boards with let's say a screw going through the.
Well, if it's screwed down, I would definitely use the mount pad. If it was one of these slotted or
like butterfly clip kind of thing.
Yeah, then I would go to the sort of our standard standoff definition, which allows some rotation.
Okay, the cheaper the attachment, we gotta go from mount hole to mount pad to standoff to some extent.
Yes.
Okay, kind of a good guideline to follow.
Yeah. So if it was, if you were screwing down to a very stiff metal chassis with no standoff, I would do the mount hole.
Okay. Okay. And I'm gonna make another hard one. You ready? What if I was kind of like gluing my board to like aluminum pad?
Mount pad.
Still a mount pad, because it's pretty well constrained at that point.
Yeah.
All right. That actually is very insightful for me. That's very useful. All right, so we've got this mount pad. I guess we'll go back to our mount hole, right? Mm-hmm. We decided you should always do outline constraint. Outline constraint. Okay. Click Save. It looks absolutely beautiful. And I think we've done a decent job of explaining. Now, I guess you can also delete a mount pad, right?
Yeah, it's very easy to delete. There's actually two ways. You can right-click on it and just delete.
What's the other way?
You can hold down the left Shift key and draw a box, multi-select, so it can delete more than one mount pad at a time, or mount point.
And then once I've got, okay, I'll delete this. I think we'll do it this way.
Yeah, it did work.
Click yes. Now, should I hit save or should I hit apply?
Either one. So apply, will keep open the mount pad editor or the mount point editor.
Oh yeah,
save and
okay.
we'll close it. Right. So the save is an apply, close. Apply is just apply.
Well, that was very helpful. Is there anything else we should know about mount points and mount point editing here inside Sherlock?
Yeah, there's certain things that you can do or that you want to avoid doing, which is placing mount points on top of one another.
So if we were to take this again, let's see.
Dr. Hillman was not associated to a hole.
Or not associated with a hole.
Yeah, so just form a new mount point or copy that mount point. Actually, you might as well you can right-click, copy mount point. Now drag that over top of the one in the lower left-hand corner. That is something you want to avoid.
That's bad. And you can barely tell they're there.
Yeah. But if you
zoom in,
you'll see them.
You gotta be careful. Oh yeah, you can just barely see that there's two there. But if you do that,
it'll cause a meshing error.
Right. So never put one mount point on top of the other. One mount point's enough. You don't need two in the same place.
Correct.
Right? It doesn't make sense from a physical perspective anyway.
Exactly. Well, sometimes you screw a standoff on either side together.
Oh, okay. Yeah.
Oh, there you go.
See, oh yeah, see?
The one that's associated stays, and the one that's not moves along.
Tells me which one to delete. Now I can. These little red squares allows me to kind of resize.
Yeah, you can grab it and resize it if you want. You might have to be inside the board outline.
Oh, look at that. Because we can't have mount points outside the board outline?
Exactly. There's also another limitation where you can't have any of the 3D mounting configurations, such as standoffs and mount pads, cannot intersect a component inside the board outline.
Well, in the real world, I guess that wouldn't make the component work very well, would it? No. Can I drill a hole right through my component? All right. Great. I guess I'll go ahead and delete that. All right. Well, Dr. Blow, thank you very much. This was a learning experience for me. Hopefully a learning experience for our audience. If you have any other questions, please check out the Sherlock User Forum or call us at 301-474-0607. I'm Craig Hillman.
And I'm Nathan Blateau.